Good morning, everyone. I want to extend a warm welcome to each of you as we gather for the fifth day of our National Level Faculty Development Program on Structural Equation Modeling with Amos and Econometric Analysis with UVA, organized by the Department of Commerce, Kristu College, Autonomous, Bangalore. From the last 4 days, we have immersed ourselves in world of structural equation modeling using Amos, exploring its application and potential. Today, we are shifting gears to focus on econometric analysis using e-views. This is a great opportunity to further expand our toolkit and learn new techniques to enhance our research and teaching practices. We are fortunate to have an expert facilitator with us today, Dr. Ankit Saxena, Associate Professor, GMA University, Madhya, who will guide us through the intricacies of e-views and its application in econometric analysis. Their insight and guidance will slowly enrich our understanding and open up new avenues for our work. On behalf of the entire Jayanti family, a warm welcome to you, sir. I am honored to extend a warm welcome to our participants from different institutions nationwide. Your involvement enhances our learning journey and encourages collaboration. I would also like to welcome FDP convener, organizing committee, and all the faculty members of Department of Commerce who has been a pillar of support in organizing this effort. We warmly welcome each and every one of you. Now let us invite Dr. Ankit Saxena to begin today's session. Over to you, sir.
Thank you so much, ma'am. And I was just wondering yesterday, I thought we'll be starting this FDP, and the moment I realized the 4 days are over. So we are done with the first leg of the FDP theme, and the intent, was, in the beginning, as we discussed, most of the participants, as they voted and shared their learning level. So the idea was to bring them to a level where they can actually feel that it is doable. Some of the basic things, which sometimes which we don't, practically do, though we think that it is very difficult. I guess that taboo has been broken by now. So that is what the idea was. I didn't, went in deep in the statistics at many times deliberately because me saying those technical terms, may be easy. I can come prepared and I can deliver, but at times, this kind of interaction that might be like something is beyond our understanding level. I deliberately kept, that explanation to a level which we can relate with. Similarly, now we are moving to the second part of the analysis today, that is econometric analysis. And all of us, most of us may be hailing from the commerce background. So I basically chair the, finance domain at my place. So we are more of the time, we are interested in the macroeconomic variables performance, some kind of stock market data, the forecasting kind of thing, spillover effects, the interaction things, and lot many, things to do with the actual time series kind of data. So we'll be, focusing right now on that particular thing. One, a book that I will recommend you all if you want to develop a broad understanding of the, econometric analysis. If you want to build from the basics, so there's a book from Gujarati. There's a, there are 4 parts of that book. So if you can refer to that book, for the basic understanding of the, econometrics, it will be great for you. I've gone through that book 3-4 times. And still, I find lot many things to learn and revise from that particular book. So it is a wonderful, wonderful thing. And if you once you have gone through the Gujarati book on the econometrics, then you can try and refer to the Alexander. So these are like one of the there are other books also which are equally good, but these are 2 basic reading pre-reading things that I normally recommend to my students or the PhD scholars while coming to my class. Before that, at least they must acquaint themselves with the basics of the econometrics. However, in next 3 days, what we are going to do, the plan that I have in my mind. Today, I'll be briefing you about the basics of the time series analysis, and I'll give you a brief overview of what are the various possibilities, which we can explore in this particular software. this software is specifically meant for the time series analysis. So there are a lot many things which it offers. Uh, Even SPSS, has its forecasting module. We have not subscribed for that particular module. It's a costly one. But if you have access to that particular, module, so it is also SPSS is also offering one particular, vertical on that thing. So that is another thing. So eViews is technically, meant to handle the time series data. So we normally use it that way. So let us quickly start with the basics, and then we'll move on with the eViews basic functionality today, and then tomorrow we'll be running some advanced test, and the last day will be taking it to the maximum levels we can take in that duration. Aman, can I get the screen sharing rights?
Yes, sir, it has been given to his family.
Just a minute. Okay, I can. Yeah, it's there. So before moving further, we'll quickly, you know, uh, go through some of the basic concepts of time series analysis. And I've been very happy. Let me tell you one mid FDP feedback from my end. You will be giving feedback about your learnings and the way I could deliver things to you. But at times, these online FDPs, whenever we participate, most of the time they become monologue. So I'm very happy, the participations and the questions and the interaction has been there, which is a nice thing. So I wish to continue the same in the next 3 days as well. So that has been the USP of this, FDP program by this point of time. So we'll continue with that thing. It takes away a bit of momentum, I understand, but I guess killing queries at the time, they are coming up. It's also not a good idea. So we'll continue with the way we are going. So you can freely drop your queries, and if I'll be answering that thing in the coming session, I will definitely refer it to that session. But if it is important, we'll definitely answer that. So let us begin with the basics of the time series analysis and what we do actually in the time series analysis. Time series analysis, as the name suggests, we are talking about something that has something to do with the time. So we'll be having a data, points which are recorded over the time. So most prominently, you have the stock market data. You may be having the macroeconomic variables data. I'll share some of the good resources with you where from you can retrieve a lot of time series data also. You might be knowing that already, but we can refer to those publicly available databases for our studies and analysis. So we can retrieve data from there, and this data has to be consistently recorded at an interval. So let's say if I'm working on daily prices movement, if I want to check, what has been the volatility in these capital market on the daily, price volume or whatever. So that, periodicity is very important. So when we have daily data, so we'll be able to make interpretations from daily, time series kind of things. And if you have monthly or yearly data, then you will be working on that data accordingly. So the only thing is, you have to be very, very careful about this periodicity as well. Let's say if you're working on a monthly data and you say I'll be working on 3 years data, that is going to make total observations to only 36. So when you're working on monthly data, you should go and have the larger span of your analysis so that you have substantial number of the observations to analyze. So that is something you should keep in mind. If you're working on yearly data, so you'll be having one observation per year. So obviously you have to expand the span of your analysis. There's no fun doing analysis on yearly data and you have confined your research only for 5 years. It will make no sense. So there has to be a substantial amount of data. So that's why normally we refer to the daily prices data or something like which is available on a smaller frequency. So the larger the data, the larger the capturing of the deviations and other things can be done. That is what the purpose is. Now, what we do in the time series analysis, there are various things that we normally do. Let's say if I have the data of sales of my company or the profits of my company or the demand that is being generated, in terms of quantity demanded for my company's product, I will like to see the patterns in that data. So is there any pattern? Has it been constantly growing, or is there some seasonality effect in it, or some kind of other irregular variations are there? So I want to capture that thing, as a policymaker. I would love to see the trends in my numbers, so how they are going in the larger when, how they are going. And then, what are the relationships? So how one particular variable relates with the other variable or the set of variables. And then, we can use the forecasting and decision making, can be enhanced with the help of these understanding. So time series analysis is, primarily, our forte. So someone was, asking this question on the day one, that the application of the analysis for the commerce thing. So this is actually meant for that purpose, to be honest, because here you're normally relying on something that is secondary data, and you have collected that data from some, let's say RBI portals or Nifty, NSE or BSE sites. IMF and World Bank also have their databases of world economic numbers, so you can refer to that database as well. So once you get these data, you will like to see the patterns, trends, and relationships, and accordingly you'll be using that understanding for forecasting and decision making. And let me tell you, this world is, this time series analysis thing is something, I'm very good at statistics. I can rate myself 90 out of 100 on statistics, but time series analysis is something that still I'm learning. And I've graduated 20 years back. So 20 years down the line after my graduation, still this is a stream that I still find short of my, desired to be, proficiency level. So this is something that I still admire to master one day. So I'm still learning that journey, and there's a lot of things every day when I pick up some, thing. There's a new topic that comes in, and we keep on learning that thing. So this is the beauty of this subject. So statistics, like, is a statistic, is static in nature. You know what is correlation, you know what is regression, you know what are the various types of tests and other things, and multivariate analysis and univariate bivariate analysis, and you know a lot of things by that. But time series analysis, is very, very vast, and lot many things will come here. Probably, if you have heard of it, that will be great. If you have not heard of it, I'll try to explain that in simple terms. So before moving further, a quick response I want. How many of you have worked on the e-views earlier? You can quickly respond in the chat box. So if you are new to this software, you have not done it earlier, then I'll be again taking you from the basics. And if you have worked on it earlier, then we can start from that level. So majority of the responses I'll capture. So a quick response you can share in my in the chat box. So those will say new and beginner. So I've got Lizzie, Nandini have been very regular and prompt participants. So, okay, Dr. Bhushan, thank you. So we are finding a lot of people, those who are saying it is new or beginner level of things. So we will start from the basics, don't worry. So uh, my idea is always that let us cover, the things in a way which makes sense to the learners. So I got my understanding for the session. Thank you so much for the responses. Thank you so much. So let us move on now. So I guess the time series analysis basics is clear to you, and we'll also be using this knowledge to the further types of things what we can do in the EVs. Now, what is the importance of time series analysis? Practically it is very much important. So when I teach my finance students, I normally dedicate few sessions for this time series analysis, whether this is part of their curriculum or not. We do conduct some value-added courses or something like that, so that the interested students can attend and understand the implications of the time series analysis, because this is going to immensely help in making decisions and making informed decision. That's what I'm saying. So if you want to go like weather forecasting or inventory management or cash flow projection or profitability things, sales projection, accordingly what is the impact on the overall EBIT, EPS and other things, it is very much needed. You have the past data for that purpose, and you can refer to that past data and make some you know uh, rational and logical forecasting on the basis of data that speaks for you. So this is very, very important part, and using past information and using that particular information for making future projections and decision making is one thing. There are a few key concepts here that we will be using, so I just want you to familiarize with these terms, so that when I'll be using these terms, at least you should understand what is the. Just a minute. Ajita ji, I'm muting you for a while. If you have any query, you can raise your hand and then ask. So autocorrelation and partial autocorrelation, these are the few things, the moment we'll start talking about stationarity and other thing, we'll be doing that. So Let me just explain that term stationarity to you in a while. As of now, we are discussing, few terms which are going to be much frequently used in our analysis. So you all have heard of correlation. When we correlate two variables, we try to establish a relationship between two variables. Normally, we refer X and Y that way. So when we say that there's a law of demand which says that whenever the prices go up, the quantity demanded is supposed to go down. So there's a negative correlation between these two variable. So the quantity demanded is going to be negatively related with the prices that are being charged by the company. And there are other theories. This is a negative correlation. There are other theories of positive correlation in that way. Now, correlation, requires two variables because we are correlating two different variables together. So price and quantity demanded are two different distinct variables. But autocorrelation, what it means, and it is a very, very popular term in time series analysis, that we are, let me give you one example. I scored, 82% in 10th. I scored 83% in 12th. I scored, it is a random data. I'm not sharing my credential. And I scored 84% in graduation. So projection for post-graduation score is, slightly easy because I've been scoring 82, 83, 84. Any layman will tell that, okay, you may score 85 in the post-graduation. So what we are doing, we are, understanding and predicting the variable value based on its own past values. So we are not relating it with the times of hours spent for the education and other, factors which might affect your academic performance in terms of marks. So we are, predicting a value based on its own past value. So we are correlating the variable's value with the past values of that particular own variable. So normally, what happens, we do that X and Y kind of correlation analysis, but in time series, let's say I want to predict Nifty values for the next week or next month. So what I can do, I can obviously do two types of analysis where Nifty is depending on some other variable. Nifty performance is depending on some other variable. There's another kind of model where Nifty values, Nifty returns will be depending on its own return values in the past. So when you relate, measure the relationship of one variable's, current values with its own past values, this is what we call autocorrelation. And I hope you must have heard of that term of partial correlation also. So partial correlation is like you are comparing, establishing a relationship between two variables, but you are controlling for the third variable there. So I say X and Y are related, but their relationship is moderated or controlled by a third variable. If I want to remove the effect of third variable, I'll be calculating the, partial or partial correlation. The same thing can be used in the, single autocorrelation also. So the variable, here X and Y are changing. So there's no X here, there's Y on Y. So Y current Y and past Ys we are correlating. That is why we are calling it autocorrelation. And if you want to control that effect for one particular variable, you can do that. And that is what you will call partial autocorrelation. And these are very helpful, at the advanced level of econometrics. Initially, I was not aware. When I started doing the time series analysis, I was like, huh, I knew the meaning of these two terms, but how to use them, that was not clear to me. But these are very helpful in terms of deciding the appropriate lag lengths and in the models. So what is lag length? Like lag length is whatever is happening in the time series today, how much time it will take to reflect its effect in the data in the coming time. So that way, the autocorrelation values, if autocorrelation, let me explain you in simple terms. If autocorrelation, starts weakening after that particular time, then that probably effect is weakening out. So that you can read out, what should be the ideal leg while creating complicated time series models. So as of now, I hope you got this term. Autocorrelation is correlating a variable with its own values, past values. Partial autocorrelation, when you control this relationship with, for a third variable, that is what you do in the partial correlation. This is what we call the intervening variable. Now, the very important thing, and the first thing that we will actually discuss today, and that is what you call stationarity. Uh, and why it is important, let me explain you that thing also. Uh, you might have, few friends or relatives or some social creatures in your life, who are very constant in terms of their reaction to you. I can give example of my mother. So she has been the most constant, in terms of her behavior towards me. So you will have one of your friend, one of your brother or sister who's constantly there for you, or whatever tough time comes, that person is going to stay with you. So you know that reaction, what kind of reaction will come if the situation, gets better or worse or whatever. So that stationality in the behavior, is there. I'm correlating it with some off the track example, but that will make you understand, what is the relevance of stationality in the time series data. And you might have some of your friends, some of your relatives in your family who are so uncertain. You can't tell, what is going to come your way next day. So their behavior is not at all stationary. And there are few people, I face in my life, and I don't know what is coming my way today. So I am quite a stationary kind of person, but their non-stationarity is a difficult task to deal with. So that way, what happens, what I'm trying to make you understand, data also has these attributes. So if you want to make forecasting, I hope you got my point. If you want to make forecasting, so it will be for me, what example I gave, for me, it will be easier to forecast the behavior of my mother because I know how she reacts in all these situations. She has been a constant, kind of behavior always for me. So that way, to predict that behavior, is easier for me. But at the same time, the person we are quoting about, the person who's not constantly behaving to you, to predict something, from a non-stationary data is a very difficult task. So whenever, let me tell you what mistakes we commit. One of my professor was working on some time series forecasting, and he is a novice person, and he's just started his career. So he just came and he was working on a data, and I was we were sharing that insights about the things. And some way he was not aware of this concept. And this is truly acceptable. It is truly acceptable. Econometrics is not a cup of tea of everyone. So what he was doing, he was statistically sound. He knew the regression and correlation and various other advanced methods of the statistics. But what he was doing, he was working on the Nifty closing values, and he was developing a regression model on that basis, that he was developing the regression model on the basis of Nifty values, and he has taken some indices of foreign countries, trying to see some spillover effect among the nations, closing Nifty values and closing Dow Jones values and so on. So what I suggested him, that you are working and developing a model, product forecasting model, where the variable that you're taking into the consideration is not stationary in nature. And I'll explain you why I'm saying that. So the closing values are normally non-stationary in nature. So you cannot develop a forecasting model on a variable which is not stationary. And you can relate to my explanation, which I have given you by now. So if the data is being used for making any forecasting model, you have to ensure that data is stationary. And you need not to worry. eViews offers you the solutions for that purpose. The most popular test is unit root test, and we have various tests in that branch. So we can use ADF test or KPSS test, Phillips and Perrin test. So there are not many tests which are meant for checking the stationarity. So today we'll do that thing in a while. I'll do it just after I complete the explanation of these two tests. So we are covering in the PPT. I've covered two things here. So I'll show you that thing later. This is the popular test here. So there are two popular statistics test which we can use here. That is called augmented decay Fuller test, ADF test, and it analyzes whether the time series contains a unit root or not. So if that is, whether the data is stationary or not. What you should remember, though the good thing is eViews also provides the null hypothesis, but still you should remember the null hypothesis, will be that series that you are analyzing is containing a unit root. That means no stationarity is there, non-stationarity is there. So you want this null hypothesis to be rejected, let me tell you. So this is the point, you want your null hypothesis to be rejected, because when it will be rejected, then you will say that data is stationary. So the ADF test, you want your null hypothesis to be rejected. If it will be rejected, then you will be able to say that the data is stationary. And how will you reject or accept a hypothesis? The basic thumb rule. So if the p-value is less than 0.05 for this particular test, we will be able to reject the null hypothesis and will be able to comment that data is stationary. Very similarly, on the same thing, I'll just exhibit this thing to you. The very similarly, we can use a KPSS test. It is also used for the same purpose. So in this case, but the only difference is that null hypothesis that a series is stationary. So in this case, when you will be making interpretation, so please be sure that your null hypothesis is going to be reverse of what you used in the ADF test. That's the only difference. Otherwise, machine will run the test and give you the output here. So let us we'll continue with the basic terms, continuation, but I want to show you how we do this in the, EView so that it will be hand-on-hand things. So why by now we have discussed the utility of time series analysis. We have talked about the partial and autocorrelations and partial autocorrelation. We talked about basics of the stationarity and the implication of a stationarity for forecasting. So it is very important, we have to see the thing. And another thing that is very important in terms of key concept that we want to discuss here, and that is the seasonality part. Because some of the time, the time series analysis may have certain seasonality. So seasonality means, let's say, obviously when we say seasonality is a normal example that comes to our mind is umbrella. So normally umbrellas are needed more in rainy seasons. So the sale of this particular product is bound to have more the, hike in those months where the, it is like July to September. So where it is a rainy season in that particular part of the country. So when you go and talk about such seasonal products, so ice cream used to be earlier a seasonal product. People used to have it more in summers, but now people are changing their taste and they are having it substantially in winters also. The psychology is changing, so they are also advertising in that way. So, however, the more consumption of the ice creams will take place in this summer part. So there's a seasonality element involved in the data, and you want to always, when you want to make prediction, you want to be sure of that prediction. So you want to know what is the seasonality effect. When I'm talking about the data, I want to, actually, this is a complicated thing that I'm saying right now. What mistake we say do, in forecasting our data, very first mistake is we ignore the concept of stationarity. So that has been explained to you. The very first thing we will do before making a forecasting model, we will check stationarity. Second thing is, we are making a, forecasting, and we are ignoring the seasonality part. So let's say if I'm making a forecast for next quarter performance, and the next quarter performance is a seasonalized high value quarter. So what will happen? The projection of mine, if I'm using least square method, will be linear. And maybe this linear projection does not fit well with that high seasonal effect. So that way my forecasting will be faulty. So what I need to do, I need to understand what is the nature of seasonality and trend, decomposition in my data. So I have to forecast the trend value and then adjust my, forecasting on the trend value for the seasonality effect. And this is what we normally do. So I'll try to explain that process to you. So this is another very key concept in the, time series analysis. So by after this, in the coming, I'll be taking this PPT again and again. So we'll be going with the time series models and the various types of tests we can do. So as of now, I'm stopping here, and then we'll, go to the eViews and explain you the basic functionality in the eViews for today. So we have approximately half an hour, so we'll be able to work on the basics of the eViews today. So let us first of all open the eViews. I hope all of you have, you know, applied for that student version of the eViews. I shared that link. So once you, you know, register for the student version, the eViews, gives you a temporary license for that learning purpose. So you need to just mention your email IDs and basic information they will ask you for. And it takes some time. It is not a very prompt service. Sometime in our classes, we have seen there has been a lag of 48 hours to 72 hours. So once you, submit that link, they will share that product key with you, and which you can use for the, learning purpose and demo purpose of the data. Then obviously, if you want to work on the data, you need to find a library or university which has the access to the eViews. So that way you can work on it. Uh, the moment you open this eViews, you will see this kind of, window pops up. Right now, I'm closing this window and I'm just expanding this eViews thing. So in this case, uh, what we see, there's nothing like, possibility of data entry. We don't see any possibility of data entry. It's a very, very plain surface. It is even, far more weird than the Amos interface that we saw yesterday, and in last 4 days. So we have nothing here. As of now, we don't see anything here. So what we need to do, first thing, we have opened the Amos. The Amos has been opened. The very first step we have done. Yeah, Diksha ji, reviews 12 is fine. It is, I guess, recent version, one of the recent version. Reviews 12 will work. It will have some added on advantages, the versions. As of now, in this laptop, I'm using again some other laptop, so it is having EViews 10. So EViews 12 will be fine. Some of the options will be, more available over there, but that will be basics will be the same. So let us go to the neat file. Okay, one more thing. I guess let me check. I've shared one file of Nifty data. Has it been shared in the group? Otherwise, I'll request Eva ma'am or Aarti ma'am to share that.
Yes, sir,
In
I
the,
have said.
thank you so much, ma'am. So there's a file that I am sharing in your WhatsApp group, ma'am is sharing. So it's a data which is comprising the Nifty values. I'll show you the data structure here, how the data looks like. So in this thing, which data we are sharing with you, what I did, I'm just saving some time here. What I did initially, I downloaded the data of these indices from, I don't remember, probably I downloaded from the NSE site itself. I'll tell you from where to download. That will be another segment. That will be the last segment of the day. So we downloaded this data from the Nifty site, I remember. And then otherwise we can download it from the Yahoo Finance also. That is also doable. So these are the, last 1 year, a particular 1 year duration data that we have here. So this is a 5 6 months old data, but demo purpose it will work well. So what we did, we downloaded all these indices data. All the indices data that we will download will have four values: opening value, highest value, lowest value, closing value. So as of now, for the beginner, we are taking only the closing values. So in this data set, if you will open in the Excel file, you'll see that we have the Nifty 50 data, IT sector, healthcare, consumer durables, FMCG, mid cap 50, small cap 50, and multi cap 50. These are sectoral indices and some broad market indices, and we have total market data as well. So what we have done, we have taken the closing values here. So that work was done. We downloaded each file. We copied the closing values of this file in one master file that we call, and we have calculated the returns here. So returns, normally when you calculate returns, let me just show you if I, tell you how do we calculate returns. So if I want to calculate returns of Nifty 50, so if I want to calculate returns of Nifty 50 here, so how we normally calculate these things. So let me just hide this all so that you can see that step clearly. There are two ways of calculating Nifty 50 returns. So though I have already calculated, you need not to do that step. I'm just telling you the methods which are used for calculating the returns. I'll be not saving anything that I'm doing to this file right now, but I just want to show you what we have done in the dataset. So, okay. So this is the file that we had. This is the closing values of the Nifty 50. So we just, very basically what we have done, we have calculated the returns of each index that we have taken in our sub collection, data collection. So there are two ways of calculating returns. One is the very popular and old method, that is the total return or nominal return that you call P1 minus P0 divided by P0. So that is current value minus past value, previous value divided by previous value. So current value, first you should have a bracket. Otherwise, what normally mistake people commit, they go down with the formula P1 minus P0 divided by P0. So eventually, if you're not putting a bracket at P1 minus P0, so the board mass will come into picture and P1, will be left separate and P0 upon P0 will be solved first. So that will not be a good idea. So you have to be careful about these fundamentals. So this is the P1, today's value, and then minus previous value, and then close the bracket and then divide by the previous value. So B3 minus B2 divided by B2. That makes sense. So you can click here and this will come in that way. You can convert that to percentage. 3 4 decimal points will be sufficient. And then you can drag it and the value will be calculated for all the indices value. This work I have already done in the datasheet. And there's another popular way that is more popular because some of the mathematicians have spoiled the finance for good reasons. So the log returns, they normally quote of log returns. So there's nothing like if you know basics of log, in the mathematics, so that's how ln of x upon y, that p1 upon p0 is equivalent to this what we have calculated. So they use the natural log here, so that is ln, and you can just use ln, that is current value divided by previous value. So this is very, very close to this value that we have manually calculated, but this is what you will call log returns. So in most of the papers of the econometrics of time series analysis, you'll find that they are working on the log returns. So when you are working on the log returns, you have to calculate log returns like this. So you just click here and then you can convert this to percentage again. And in percentage, we are taking, let's say, 3 decimal points. So very close to what we calculated in the normal traditional formula. So either way, which is convenient to you, you can use it. I'll advise you to calculate the log returns. What data we have is all about the log returns. And then you can drag this formula for all the indices that you have copied and pasted, and this way your data sheet will be prepared. So the first step is downloading data from different portals and comprising and finalizing your master data sheet that you want to work upon. So for this master data sheet that we have worked upon, what we have done, I'm not saving anything that I've done in the data because I will import this data in the file. So let me just reopen it. So what we have done in this master data file here, from each individual file, we have copied the closing values of that particular sectoral or broad market index. And then we have calculated returns for each sector that we have taken for the analysis. So this is how we are moving forward. You can take indices of one particular country only. You can take indices of multiple countries. You can take data for any macroeconomic variable on the same periodicity. Please be careful when you're working on a daily time series data analysis. So you have to find all the variables in your analysis, all the factors in your analysis which are actually available on the time frequency of day. So which is the first condition. You cannot, you should not, try some analysis something like which is the values which are available on monthly basis with the daily frequency data. That makes well no sense here. So that is one thing that we have done. I've got a query. Yeah, Diksha, we have taken Nifty or all other indices closing prices only. And on the basis of closing prices, we have determined their returns. So that's what we have done. So this file is with you. What I'll advise you, you can, I'll tell you the website resources also. You can download 3, 4, 5 indices data from there and then rerun this analysis according to your understanding. So this is what we have done. So we have data of Nifty and some other sectoral and broad market indices and their returns that we have calculated using log returns. So I'm coming back to the eViews now. The first step of using eViews is going to be importing a data file here. Just a minute. So what you will do, you will first of all import the file. So you go to File, you go to Import. Let me tell you why we are seeing these two types of areas here. The first thing is you can use the eViews with the help of commands also. So there are specific command for doing all the test, which I'll not be covering right now. I'll be using eViews right now in the 3 days as if like we are using Excel or SPSS only. So we have every option available at these clicks also. So that is there. So we'll be using these options right now. The if someone who is proficient of working at R or Python, so they can try of using the code command prompt here in the eViews also. As of now, and the first few days of beginning things, and still even today, I use most of these click and drop down menus only. So I click on the file, I click on the import, and I'll import from the file. And I will click quickly on the file which I have been using. So I have this data at this folder. So you reach to the file and you get this Nifty data somewhere in your download folder by now. So you can click it and you just open it. So the moment you will open it, this will have few steps of reading the Excel file and it will ask you few things. Let's say by default, it has done, it has taken the first row of the data sheet that I've shared with you as the, header, which is okay. I wanted that. So normally we don't change anything here. We just click next kind of thing. So let's say if you want to have some predefined range over here, you can actually custom the range also. So as of now, it has taken the sheet one. There's only sheet one in my data. If my data would have have more than one sheet, so I could have selected sheets from sheet 1, 2, 3, 4, 5, this kind of thing. And if I wanted to specify a custom range, I don't want to take everything from A1 to 249. I could have customized the range also. So normally I don't use that option because we know what data we want to work upon. We have worked on the same data set and we are bringing that same data set in the eViews here. So we are not changing anything over here, but these are the utilities that we can try. Then we click on the next, and it is asking you the header name and other things only. So header type is names only, and that is good enough. And then you go on. If text representing NA is like some missing values are there, then it will be taken them as missing values over there. So we don't change anything here. I know there's no missing values in my data. And then click next, and finally it will import the entire data that we want to bring in the views. And the moment you click here, there's an option of linking imported series and alpha objects to external source. So if I make some changes in my dataset over there and I want eViews to run, link my file, so I can say yes. If I say no, then it will not create that linkage there. So if I change anything in my data file, that will not be updated in my eViews, work file. So if I wish to link it, I should link it. So it is like I'm working on a rough data. I will be having the final data by the end of, let's say, this month. So then I should link it so that when I'll update my data file over there, that linkage will help me in terms of continuing my analysis without redoing this step. So, well, I'm just linking it, saying yes to it. And what you see here, you'll be seeing this kind of, you know, uh, work file. So Nifty, what it does, it keeps opening the work file like that. So every thing that we are going to do, it will be on this kind of thing. So let us have that understanding. So what we were talking about in the initial part, I was talking about the stationarity, and I want to check the stationarity, and I'll tell you 3, 4 methods of checking the stationarity. This is the first ever step of making, especially if you are talking about some kind of forecasting. So you must be doing that forecasting on the basis of some stationary time series, because the forecasting normally requires, this is a precondition for forecasting any data series. So here I want to check whether the Nifty closing values are stationary or not. So what I'll do, I'll go here and click on the Nifty 50, and I'll just click here. I'll just, I've selected Nifty 50. These are the closing values of Nifty 50, and I'll click here. And what it will do, the eViews keeps on creating a new set of, work file like that. So we will have another work file here. So we got another work file. So this is the another work file that we have got, which is okay. Now what we are going to do, we want to see whether this data is stationary or not. So there are 2, 3 ways of doing this entire thing. I'll tell you all the possible ways of doing that thing. So eViews allows you to operate, via again multiple ways. So as of now, what is the easiest way? What we have done, we have clicked on that variable we want to work on. The new work file has opened, and I'll go on the view. So I'll click on the view here, and in view, you will see there's an option of various things that we can do here. So today, the first thing that we are doing, we are checking for the correlogram. Now, what is correlogram? It is the diagram of correlations. So autocorrelations and partial autocorrelations, AC and PAC. These are the abbreviations that the eViews will offer to these terms. So AC is autocorrelation and PAC is the partial autocorrelation. So the correlogram is basically going to give you a correlation diagram, and it offers a basic understanding about the you know uh, stationarity also. I'll explain you how we can check that. So if I click on the correlogram here, it will ask me for the correlogram I want to make for the label. And at times, when the data is not stationary, how will you work on the data? So either you take some differentiation over there, or you convert that data into some other way. So like we have done. So what we have done, we have taken a kind of stationarity step we have taken. We have converted the raw closing values into the returns, which are relative values. You can understand, return values will, daily return values of Nifty most of the time will not range very much away from -2% to 3%. Majority of the time, the ranges will be -0.5% to 0.75, 0.8%. Daily, you won't see upsurge in the market or downsurge in the market of higher level. Exceptions may be there. One odd day, one odd week may be there, but majority of the time, out of 240 days of the working, Nifty, will probably trade in that particular range. Few percentage upside and few percentage downside. So we don't see 15%, 20%, circuit breakers every day. So that way we are going with. So we are taking the level, the closing values only. We're not differentiating or we're not moving for any transformation of the data. So we are clicking here. So let's click here, and you will see this kind of data. Now what I'm doing at the same side, because I want to make you understand the comparison of a non-stationary and a stationary number. So I'm opening the same, data of return of Nifty 50. So from the Excel file where we have data of closing values of Nifty and the return values of Nifty 50, we are opening the return values of Nifty 50. So I'm just opening it again and I'm taking it on the third box here. So every return, everything that you will open, will emerge as a new work file here. That is how eViews operate. It's a slightly different software, the softwares that you have worked upon by now. I guess if you're working on the eViews for the first time, it is the most unorthodox kind of software that you work upon. So they work in a very different way. So the data comes in this way. You don't see even data. So for clicking on the data, seeing the data, you click on the data, you can view the data like this only. Now what I'll do, I'll go and follow the same step. I'll click on the view and I'll click on the parallelogram. So this is how I will develop the parallelogram of the things. Now on the mid box, the left hand side box, first box on the left is basically the work file where I'm having all the data sets which I have in my data file. The second box in between here is the work file of Nifty 50 closing values. And the third box on your screen right part, you see that is the work file that is actually referring to the data of the Nifty 50 returns. Now, what is you can make out from here? The autocorrelations in Nifty 50 values are very high, right? They're extremely high. Even the partial autocorrelation, which you see, on the first leg is very high and then it goes down. So very first thing, if you want to make a comment on the stationarity, what you will see that autocorrelation values are pretty high for Nifty 50 and they are within the range and very static for the Nifty 50 returns. So which is likely to be a stationary data series, Nifty 50 returns. We cannot be conclusive about this statement, but this is how it goes. Let me make you understand. There are three conditions for checking stationarity. The mean of the data over the time period should be constant. The variance of the data that we are analyzing, we are analyzing only one single point of data. So Nifty closing values, mean. Obviously, we are talking about average, moving average. So that average over the time, should be constant. So moving average should not be very, deviating too much. Then the variances of the series over the various time interval has to be constant. Another thing is the autocorrelations of the data should be constant over the time period. So these are three requirement of any data to be called stationary. So here what we are seeing here that autocorrelation values are pretty high for Nifty closing values. You can see the values here. The autocorrelation values are above 0.9 and 0.7. So these are high values, autocorrelation values. Even the partial autocorrelation for the first part is very high and then it goes down. The Q stats values are pretty high and their probability value is less than 0.05. So here, two things that you should keep in mind. If autocorrelation values are high and if the probability value is less than 0.05, it is a sign that your data is not stationary. I repeat, the autocorrelation values are high and your probability values of Q statistics are also less than 0.05. This is a sign where your data is likely to be not stationary. However, if you see on the right hand side, and if you see here the parallelogram of return 50, Nifty 50, the autocorrelation values are low and they are having the probability values of more than 0.05. This is a sign that your data is going to be stationary. But this is a visual thing. This is a visual thing, though we have probability values of Q statistics, but this is a less robust method of analyzing the stationarity of any data. So this is some of the papers paste this parallelogram in their analysis too, which is fine. In the appendix, they normally keep this analysis to show that what they have done, check the stationarity. So if you're working on eight time series data, what you will do, you will put the eight parallelogram small boxes in the annexes showing that you have done that analysis of studying the stationarity using the parallelogram. So you can write a paragraph about that interpretation as well. Now, the important thing is here that if I want to check it statistically, what I'll do, I'll click here and I'll click here and I will go with the unit root test. So I click on the unit root test and again it will offer me whether I want to test it at the level. Yes, I want to test it at level. Level ka matlab the value which is there. I'm not differentiating. Some of you, if you have studied scientific mathematics, so there's a chapter on integration and differential calculus, all that thing. So we differentiate one number with respect to one variable. So that's what differentiation comes into the picture here also. Don't worry, I'm not complicating it right now. So we are checking it on the level. Level means the values which are there as it is. We are not taking any first order or second order differentiation for those numbers. So we are going with the level here. If you see test type, you see these, 6 tests are available. In the, advanced versions, you may find some other options available too. But the most popular is ADF test, which we are going to use right now. I talked about KPSS test in my PPT also, so that is also available. There's also one test which is very popular, Phillips and Palin test. So normally these 3 tests are widely used for reporting the stationarity implication of a variable in the research papers. So we normally click on the augmented decay flow test. We are going with that. We are not changing anything right now and clicking OK here. This offers certain data here. And then I'll do the same thing for the return of Nifty 50. And I go on the unit root test, and by default, what is there? I'll just click OK here. So the important part here, I'll just take you back to my PPT, which we discussed, just a few minutes back. So this is the stationarity test and the augmented decay Fuller test. The null hypothesis was non-stationary. So if null hypothesis is accepted, we will say that data is not stationary. The interpretation line also I have written at the bottom. I'll share this PPT with you. So the p-values less than 0.05, is suggesting that we reject the null hypothesis, and that will mean that data is stationary. So I want to reject null hypothesis to call my data stationary. So let's say here, so where, if you can quickly comment in the chat box, in which variable we are able to reject null hypothesis, where p-value is less than 0.05, Nifty closing values or Nifty return values. So anyone who's active here, they can respond on the chat box here. Yes, you're right. The Nifty returns is having the, p-value less than 0.05, which means that, yeah, very right, Diksha, Trilmala. So yes, the return value is, having a p-value less than 0.05. Here we are rejecting, yes, Dr. Rishi. So we can say that Nifty return is the data which is stationary in the context here. One more thing, one straight away, very simple thing that I'll explain you. If you want to plot a normal chart here, a normal chart also tells you a lot many things about the stationarity of the data. So if I just click on the view and click on the graph here, though there are a lot many graphs possible, and this is meant for that thing, so you can see various things are available here. So I'm just going with a simple line and symbol chart, simple line chart to be precise, and you see this kind of Nifty data progression. Obviously Nifty has been rising in that year. It was a golden year for Nifty performance. Last week around we had a turbulence, causing from a global macro event, so which is expected. Now if you see the return of Nifty and you see a graph here, so why I'm telling you this, just making you understand side by side. So what returns are doing? Returns are basically putting your data into a range. So what I was saying, it is a normal tendency of Nifty ranging from like this is plus 0.02. That means 2% return on a day was achieved in that flag, and the lowest return was also like somewhere below the 0.02, that is minus 0.22, 0.323%. So we can see the minimum and maximum numbers on the data. So if I tell you, if you want to make projection, you can say projection can be made here also because the data is only going one way up, which is fine. But sometimes the picture may not be that clear. So if you look at the data, at the wider range, data will be very, very cluttered and cluttered. And so then if you want to make prediction for next week, next 1 year, the rising data, will show you the rising numbers only. So that may be a disaster. So to make prediction here, will be slightly difficult. The models will not be that robust. If you make prediction on the Nifty returns, it will be better. So what we have done by now, if you just quickly revise, we imported the data file in the eViews. We saw that this is how the data comes in the data. And then we used 3 things over here. So I just explained you the concept of correlogram. The autocorrelation values are high with p-values of the Q statistics less than 0.05. It's a sign of non-stationarity. We can confirm that using the unit root test. So normally we check it by the ADF test. So we checked it. It is above 0.05. We wanted to reject null hypothesis, so which didn't happen because p-value is above 0.05. null hypothesis is accepted. This is a thumb rule. Please be clear about it. I'm taking a coursework class right now, and after 3 months of my teaching, also this line, I have to repeat in every class. So we have to bear with this line because this is the fundamental thumb rule of accepting or rejecting a null hypothesis. So p-value, if p-value is above alpha, that is your level of significance. So if you are taking 5% alpha, that means 95% confident you are in terms of your results declaration. So the error chance is only 5%. So 95% there'll be no error in accepting or rejecting a null hypothesis. So that way we are talking about this p-value is pretty high. So 0.05 uh, and above. So that way null hypothesis is accepted here. We normally say that we do not have enough evidence to reject null hypothesis. This is how we normally quote it. So we do not have enough evidence to reject null hypothesis. That means my data is not stationary. I wanted to reject null hypothesis because I wanted to claim that my data is a stationary. If your data is a stationary, you can move on to the next step. That is one thing. Now let us quickly understand one more thing here, that we saw the graph also. So these are few things that we have worked upon. Now, once you have established the stationarity kind of thing, so I could understand that I cannot work on the Nifty 50 anymore for making a prediction model. So I'll close this work file. Let me say that I want to just see how the mid cap 50 and small cap 50 returns are doing. So I'm just focusing on the return values here. So it is mid cap 50. And if I just quickly see the unit root test, I click OK, it is less than 0.05. And if I open small cap also, and I want to see how the small cap is selling, and I check the unit root test. Return unit root test, I know most of the time in the stock market will be stationary. So it is a stationary. So what we can see that small cap returns and this mid cap returns, they all are found to be stationary because all the cases PDF values, or sorry, that ADF values of unit root test is less than 0.05, which we want to achieve. So we'll say all these three values are stationary, and we can proceed with a forecasting model. So today, just to take you one step further, we will make a regression model also. I'll make a basic regression model here using EViews here. How we make regression model in EViews, you have to go on the quick. One more thing, if you wish to run the unit root test or correlogram or such things, you can use this option also, see these statistics. But here what will happen, let's say you want to apply unit root test. So it will offer you a box like that. And then in that case, what you have to do, you have to type the variable name. And please remember that the variable name you should be able to remember very clearly. So what you will do, R underscore, the way they are written. So R underscore Nifty 50. So please be clear about those spellings and other things. So you will mention that thing like that. And then you can click OK. And this will take you to the work file which is there. So I had already that work file, so that's why it worked well. So this is another way of running any test here. So what we were doing, we were clicking on the data file and creating a new work file, and then we were working on these tests, which makes more practical sense to me. But you can use this quick option for that purpose as well. Now I want to make regression equation. For that, I need to go to the estimate equation. So what I'm doing right now, we are going for the regression model. Today, we are doing a simple least square regression model. Tomorrow, we'll talk about the Gauge models and Arch models, which are having the concept of heteroscedasticity, coming into the picture. So I'll explain you first that concept, and then we'll take you to those things. We'll try to cover the ARIMA part as well tomorrow if time permits. So this is the point.
Sorry to disturb you, but here all the p-value, like this probabilities are 0.0. So this return mid cap, small cap, and Nifty 50 are not stationary.
Are stationary.
Okay.
Because we want to reject null hypothesis. The PPT,
Okay.
I showed you the PPT for the same purpose. So the low p values, will be rejecting the null hypothesis. So we want to reject the null hypothesis because our null hypothesis is basically what? It is containing a unit root, which means non-stationarity. If unit root is present in the data, that means it is not stationary. I want to reject it. So null has to be rejected. And when p values are less than 0.05, it will be rejected. Got it? Thank you. So this is how we proceed. Let us develop a quick regression model, then we'll take your queries for next 5 minutes. So if I go to quick and I go to estimate equation here, and this box will pop up like this. So now it is slightly, difficult part to make a regression model in the views if you are doing it for the first time, because you are used to different way of making regression models, and this goes and uh, define the regression in a very different way. So what I'm doing right now, I'm just clearing the work files here so that you are able to understand. It's not that complicated at the time. You need not to open all the work file for that purpose. The work file purpose is over. So we have checked whether the Nifty 50 returns, small cap 50 returns, and mid cap 50 returns were they stationary? Yes, they were stationary. The closing values were not stationary. I didn't check for small cap closing values and mid cap small closing values, but I know the closing values of the capital market, move by and large will be non-stationary in nature. You can check it. You have the data set, you can check it. Now, if I wish to run the regression here, I wish to run the regression here. And I'll tell you why I said that I'm still learning this. After 20 years of graduation, still I find myself short of the proficiency level, I want to achieve. I'll tell you why I say that. So you click on the estimate equation, you come here, you click on this equation here. How to share those work files for references? Rohini is asking. Rohini, what I have done, we have the Nifty data set in a master data file in an Excel file. So what we have done, we have just imported the files in the eViews. Yeah, we can save this for the future thing. So once you will be, you can work on this data. Let me just close this estimate equation for that purpose. So you can save this, you click on the save, and this eViews, will be saved with the precision, that you want to work on. So next time you'll not be required to import the data file again and again. So you will be able to save it. If you wish to save it at somewhere else, you can click on the save as button, and in save as button, you will see that Nifty data, eViews work file sorry, the star, that is the file name, .wf1, that is work file. So this will be saved as for your future reference. That's what is needed. So it is needed when you're working on a data for longer duration. So you wish to save it somewhere, and then you can keep working on that work file again and again. So we were quickly running the regression here, and I'll tell you why I said that I want to learn these things even more. This is something I'm still learning and cherishing that learning. So, learning is a beautiful journey. Let me tell you, I love believing in journey. I am mid age of my life, I believe, and I've learned a lot, but still that hunger is there to learn even further. That's what keep me going. So just sharing with you, I'm a man of purely commerce background. I learned Python, I learned R, I learned some other SQL languages and all. Because nowadays, companies are asking these skills in your students. So when you're training your students, you must know those things as well. So, and that keeps you going. It is the beautiful part of being an academician, I guess. So we are clicking on the estimate equation here, and it is the equation that we will formulate now. Let me say, I know Nifty 50, is a broad market index and that guides everything that way. I want to see whether the small cap 50 returns are depending on the mid cap 50 returns and the large cap or this mid cap Nifty 50 returns. So I want to check this equation here. So how the small cap returns are depending on mid cap 50 and Nifty 50 returns. That's what I want to check here. So my dependent variable is small cap 50 returns. So first you have to type here. So you will type and the suggestions will come. So you will type R underscore small cap. So it will guide you. That blue box that you see is that thing. So you can click here and this will be there. So you can tap and this will, select that particular option. The first you write and type, and then you select the dependent variable. So dependent variable has been typed. For this, we can use a code also. So if you know a bit of R programming and Python programming, then you can develop. They're not as complicated as in Python, but yeah, there are codes for running these commands in the eViews as well. So eViews is a hybrid software which works on, simple kind of things as well, and then commands are also there. So you can search for those codes if you wish, you can, but there's no need to worry about at the beginning levels. So then this was the dependent variable. I want to assign one constant to my model. I want to identify the value of intercept in regression. So I will place C here. This is a deliberate placement. So I'm putting, because I want to develop that equation, y is equal to a plus b1 x1 b2 x2. So a value I want to identify. So that's why I'm putting that C value here. And then x1 and x2, I know my x1 is mid cap 50 returns. So R underscore mid cap, and underscore midcap, and this will give me the midcap 50 data. We must take a disclaimer here that this data that we have collected was from the duration of 14th of March 2003 to 12th of March 2024. This is not the very recent data. I can share the updated file tomorrow for the next session. So this is the data. That data range has to be kept in mind. This was last financial year that we normally collected this data for. So that way, this is a few 1 month old data was there. So when I was taking a class, probably then I collected this data. So the small cap 50 return is depending. This is what we have written as the first part of the syntax. We mentioned C here, which is going to give us the value of intercept. And then we are typing midcap 50 here. So midcap 50 is my first dependent variable. Then I'll take a space and I'll write the second variable there. So you're just typing what you want to add in the model here. So the next next variable I want to add is Nifty 50. So return of Nifty 50. So no comma, no plus, nothing, only a space, and then keep writing the variables you want to write. First, you write dependent variable, space, you write C to get the value of intercept in the regression, space, first dependent variable, first independent variable, and then second independent variable. So the small cap 50 returns are depending on mid cap 50 returns and Nifty 50 returns. That's what I want to check. And when you click here on the methods, there are these many methods of regression. And our life, normally as an accommodation, normally, in the classes, we normally keep ourselves restricted to two methods of regression only, regression coefficients and least square method. And once for the first time, I was going through the e-views. It was a part of our curriculum to one particular section. And then I just thought, oh my God, these many methods are there in regression. I didn't hear the names of many of them. So then that journey started of exploring the methods of regression and what is their utility in different paradigm. So this is where, still a few are still in my, to-do checklist to complete. So I wish to complete all of them soon. So there are even more things. This is a quick thing that you're seeing there. Even in one method, you will have options of like you go with the arch and gauge kind of thing. So there'll be like P gauge, E gauge, G gauge. So within a method, there are different derivations and different application of different models. So as of now, we will restrict ourselves to the traditional method that we have understood, least square method. This is called least square because in this method, the residual squared, sum is going to be the least. So sum of the squared residual is the minimum in this set of A and B values, and that's why it is called least square method. So we click here, and then you click OK. And the moment you click OK, you will get an output of the regression here. So you can derive few important things here that I'm just typing the equation that I could make here. So the equation of the thing is that return of a small cap 50, I'm just typing it in the command prompt here, which is for my understanding, I'm doing that. So I can also use the zoom text button, but let me just type it here. Someone has asked me something, let me answer that. Sample data must be entered manually. It will not take automatically. No, I didn't get that query, Diksha. You can sort of.
So the dates which you mention at the bottom where sample is
Yeah,
written.
sample date we could modify. We could,
Okay.
if I wish to like do the analysis for the regression of the selected variable only for the recession duration. So if I have data of ranging from 2006 to 2020, and if I wish to see what happened in great crisis and what happened in COVID crisis, so I can specify that date range over there. So sometimes it is very important, to exclude even one particular, duration, we can use that function. So we can exclude a particular, duration where the market was in heavy turbulence. And actually, including those tough times in the forecasting, does not make much sense because then you're generalizing too much. So it depends on the problem that we are
So
working on.
for forecasting purpose, we can pick that particular time, whatever we have.
we
Okay,
we are
okay,
comfortable.
sir. Thank you.
That
Thank
is what
you.
the purpose. So that is how we proceed. And then if you see here, the equation we can draw. So let me just see. Okay, this will take slightly time. I'll type it here. Don't worry. This is overlapping here, so I'm just typing it here only. So could you see my screen here? No. Yeah. So I'm just typing it here right now in the command prompt itself. So our small cap returns is equal to, the equation that we could make is C value is the constant value. So we'll say 0.00238 plus 0.95915498 is the coefficient here, this value. So I'm deriving equation from this coefficient. So this is small cap 50 return is equal to the A value is 0.000238 plus this coefficient, this is B1 multiplied by X1, which is our mid cap 50 returns. So this is going to be multiplied by our mid cap 50 returns plus the small Nifty 50 coefficient is low here. So that is 0.106026 and that is multiplied by return of Nifty. So this is the equation that we have drawn. And most of the researchers make a blunder here while just developing a regression model and pasting it somewhere and claiming it to be a wonderful model. We need to see the relevance of individual independent variable. So you see this number here. This is very important number here. So this mid-cap 50 is having a probability value of less than 0.05, which makes it a significant predictor. So mid-cap 50 returns are playing a very important role in predicting the small cap 50 returns. But Nifty 50 has a p-value above 0.05. And here that significant dependency is not there. So Nifty 50 is not a significant predictor for predicting the small cap 50 returns. So we cannot say if Nifty 50 is rising, the small cap 50 will also rise. Those who are coming from the stock market and understand the basic structure of the market, they'll understand what I'm saying. So Nifty 50, they are the largest set of companies. Small cap 50, they are the largest, but largest of the smallest set of companies. So these top 50 small cap companies are there in the small cap 50. So normally, if NSE has done a very clear demarcation, first 100 companies on the basis of market capitalization, they fall in the large cap. Next 150, they fall in the basket of mid cap, and then 251 onwards, whatever number of companies we have, they're categorized as small cap. So 251 to 300, that's what we are calling. So this is the largest small cap company, but still, small cap companies are small cap companies, and they cannot be as performing as the big companies, the big giants are performing. So these Nifty 50 are giants all. So that way, what we are learning from this regression model for this duration, what comes out, you cannot be so generalizing, things on the basis of 1 year performance. You have to revalidate this statement, doing this analysis on a larger data and revalidating it at various time intervals. And say if I'm doing it annually, so let me do it for 10 years, and every time it is not doing that way. So we can generalize then that every year we found that Nifty 50 is not working as a significant predictor for returns of small cap 50 companies. So this is one important thing. So this last part of the equation actually is not a good one, because this is not significant in my regression. So this you need to understand, and you need to revise and find some other significant predictor here. That is one thing. One more thing just for the day, and then I'll close it for the day, and we'll take up your queries. That is R square. So the R square is decent. Even if you have a one not so good, independent variable in your model, but you have a one very good, independent variable, that is mid cap 50. Mid cap 50 is more aligning with the small cap performance. So then the R square goes to 0.66. So this equation that we are deriving is going to explain 66% of the variation of the dependent variable. So which is nice. But I believe if you drop Nifty 50 from the model, you'll be getting better R square value. So having someone who's not aligning well in the model, will distort the R square value. So I repeat R square value, what I said here. So 0.66 means 66% of the variation in dependent variable, small cap 50 returns, will be explained by selected independent variable. So this is the uses of R square value. So that's the point. One thing that I said I will tell you, so quickly I can share some quick data sources here which you can use. So one very popular data source is that RBI database on Indian economy. So you can click on RBI DBIE. So you'll be referred to RBI database on Indian economy. So you can just click here. It's a wonderful data sets on very very much macroeconomic things, and very all the important macroeconomic variables you will be able to find here. So you can use that particular thing. Another that I normally use for my researches, we go with the Yahoo Finance. That is So we can go with the Yahoo Finance, and Yahoo Finance, you have the data of all the leading, indices over there. So you can click on any indices here. So let's say if I want to say uh, Nifty 50, if I want to take data of Nifty 50, it will take me to Nifty 50. You can search for any index of any country that way, and then you can go to the markets here. Sorry, this is downloaded here. Yeah. So you can click on the historical data, and in historical data, the Yahoo Finance offers you a facility to download data on various intervals also. You can download data on daily basis. You can download data on weekly and monthly things. So you can click here, and this will offer that option of converting data. So you want to download historical prices from which duration to which duration, that you can play with here. So I can specify a range also from this to this data. I want to download an exchange data, so that you can use, or DBIE. I hope this page is loaded now. Yeah. So there are a lot of things which are available here. So you can just explore this thing. So you can go to the indicators and find what information is available here. You can click on the statistics here. So a lot many information is here. So you can click on those things, and you just explore this thing. You will find data on that basis. So if you go on the statistics, you will have another set of information. So every sector wise information is there, and you can download a lot many information on varied time intervals. Few data will be available on timely data, like inflation data they publish on monthly basis. So you can refer to that database, and then you can align with the similar time frame time variables, and you can put that into the any software for further analysis. So you can also refer to the IMF and World Bank if you wish to, for retrieving the global macroeconomic indicators. They have their own data banks facilitating the data availability. If you can access to somewhere like Bloomberg terminal, if your some of institution nearby you has that subscription, or your institution has that, it will be great. Bloomberg offers a variety of time series data. You can't even imagine, what is there. So they offer a lot of data. So these are the prominent sources of time series data. And we have done today basics of stationarity, making graphs, checking parallelogram, checking ADF test. We also learned how to run a regression equation in the eViews, along with basic concepts of the time series analysis. We'll move on from this in the next session. So if you have any query for the today's session, so that you can ask in the next 2-3 minutes.
Just a question on Houseman test. So is it required to do Houseman test before moving into this one time series?
We'll be covering that test tomorrow, sir. So you have to wait for that answer tomorrow. So we'll be covering that. I have taken few things here. So what are the various tests we'll be discussing about? So we'll be discussing few more tests tomorrow, so that we can see.
So you said that you will discuss GARS tomorrow. There's one question that eigenvalue is written everywhere, EIGEN.
Yeah.
So what it signifies and how to interpret that particular value.
Arch and Gauge I have not covered today. That I'll be covering tomorrow. So with that explanation, I'll explain all those terms over there.
Okay. Okay.
What I've covered today is basics of stationarity. I have covered the augmented decay Fuller test and basic regression. There were a lot many tests available in the regression.
Okay, okay, sir. So
Yeah.
one more thing, whenever we are working on a time series data, so first and the foremost thing, we have to go ahead with this stationarity test. And then if suppose whatever you said that if we are comparing the volatility or forecasting, then we can go ahead with a particular time frame. So if suppose there is a 10-year duration, like we talk about this COVID period. So if I take this particular 2-3 year, like 2021, so that will show the variation anyhow over there. So we can remove that and then we can forecast. So it is not like that we are not taking properly the data.
Yeah. So there's a methodology section in your paper. So methodology, defines the way you are doing that. So
Okay.
if you want to you want to forecast for good times, so why to take the bad times in your forecasting based duration? So you have to obviously refer to certain methodology support also. It's not like it has come in my mind and I'll be doing that. So normally papers that we will see in that duration, they normally have either during crisis, post-crisis and then pre-crisis. They normally design their paper in 3 segments over there. So they develop the regression models for 3 different durations, and a master regression also is there. So they will compare the values of R square, they'll compare the values of coefficients, how the values are distorting during the crisis values. So was there any difference in terms of R square value during the crisis time? Was it the same as if we are not discriminating between these 3 time frames? So that lot depend on the methodology that you're opting for and the base paper that you're referring to replicate further. Rohini, yes, stationality we need to check, and especially when you're moving for the forecasting kind of models, then definitely you must check the stationality. Thank you, sir. Thank you for the feedback. So I think we are done for the day. I stretched again 10-15 minutes, so sorry for that.
Okay, sir. It was wonderful, sir. Thank you so much, sir, for enlightening us with your expertise in reviews and basis of time series analysis and models, how to analyze those data we have learned today. Thank you so much. Now I request Dr. Priyanka Ghosh to propose the yoga class.
Good afternoon, all. Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. On behalf of the organizing committee, I would like to express our heartfelt gratitude to our esteemed resource person, Dr. Ankit Saxena, for sharing his valuable insight on Introduction to Economic Modeling with reviews. Leader is one who leads us in right path. One such leader is our head of the department, Dr. Vijay Kumar R. Thank you, sir, for always leading us in the right path. Adding value to our institution is the unified support of all the wonderful teachers. We thank the entire teaching fraternity of the Department of Commerce UG for their active involvement. I would like to thank all the participants for their active involvement. Your curiosity, eagerness to learn has made this event a great success. Lastly, I would like to thank the FDP convener, the organizing team, for their tireless efforts and dedication in making this event possible. Thank you all once again. I remain.
Tomorrow. Thank you, participants. We came to the end of the FDP today's session. So tomorrow, same time, we will be back. Thank you all.